We are trying to use the line integral for area to determine the area of this ellipse. Once again, the line integral for area formula is area equals to 1/2 integral over a smooth curve C x dy minus y dx. The area of the ellipse, I have x squared over a squared plus y squared over b squared equals to 1. So here is the graph. That is A, that is B. This ellipse is simply connected, and then the orientation is counterclockwise. The way we start this problem is I am trying to set up a integral in polar coordinates. So for polar coordinate, what is x and y equals to? Polar coordinate, x is equals to r times cosine of theta, y is equals to r times sine of theta. Okay, and then the r, I will be replace the r by a and b, and then the theta, we are going to replace that by a t. So I'm going to have x equals to a times cosine of t, y equals to b times sine of t. Let's color code that. So this is a, and then this is b cosine of t sine of t, and then this is like a full circle. So the t, I will let the t between 0 and 2 pi. All right, so how about the dy and the dx? For the dy and the dx, this dy and this dx, you will have to integrate the x equals to and the y equals to. All right, so this one, if we integrate the derivative of x with respect to t, what do we get? The derivative of sine cosine is negative sine. So we have negative a times sine of t. All right. How about the y? I will try to differentiate y with respect to t. So the derivative of sine is equals to, this is actually a sine of t, right? I wrote the t twice. The derivative of sine is cosine. So we have a cosine of t. Don't forget the b in front of it. So since I have a dx and a dy only, there is no dt in it, then you have to multiply the dt to the other side. And then we do a change of variable. So the dx is equals to negative a sine of t dt. And then the dy is equals to b cosine of t dt. All right, so the dx, I got it. And then the dy, I got it. They are in terms of t now, and then also the x and y is also in terms of t. Okay, we can set up the line integral for area. So we have area equals to 1/2, and then we have a line integral. Actually, not really a line integral, it's just an integral now. And then t goes from 0 to 2 pi, so t goes from 0 to 2 pi, and then we have x dy. X is now a times cosine of t. How about a dy? dy is b cosine of t dt. So b cosine of t dt, which is from here. That is what the dy is in terms of t. And then we have a minus, this minus. So I will minus y is b sine of t. And then dx is right here, negative a sine of t dt. Usually the integrand is very easy. Negative a sine of t and then a dt. Okay, what do we get? I see a sine square and a cosine square. Can we factor out the a and b? Like this, can we factor out like the a, b, and then the 1/2 is there from 0 to 2 pi. So that one will be a cosine square t, and then this minus and that minus becomes a plus. We have a plus sine square of t, and then the dt, we can take the dt outside. Cosine square plus sine square, fundamental identity. So that is a over b, a times b divided by 2. T goes from 0 to 2 pi, 1 dt. The integral of 1 dt is just a t. So we have a times b over 2, and then t such that t goes from 0 to 2 pi. That will be a 2 pi minus 0. So it turns out that the area is ab over 2 multiply 2 pi minus 0. The 2 can be reduced. So the area of an ellipse is you take the pi and then you multiply a and b. this applies to any ellipse. So that is area of an ellipse. That applies to any ellipse. It can be a horizontal ellipse, it can be a vertical ellipse, and then that is the end of this problem. So before I let you go for this video, in the next video, what I am trying to do is I am trying to put a circle inside a ellipse, and I would like to find the area between the circle and the ellipse. So that will be the next video. All right, so that's it for this video. If you like the way I explain line integral, area of an ellipse, give this video a thumbs up, subscribe to my channel for more contents like that. As always, I will meet you all in another video. Signing out.